Bismillahirrahmanirrahim. Viewers, today I will let you know how to draw a computational model using GINsim software. GenSim is a discrete modeling framework or qualitative modeling framework where you can model systems using discrete values or qualitative values. Means the precise or exact values are not known, or you're not using the precise or exact values for entities or nodes. Rather, you first discretize the values to qualitative values, and then you model it using you can model it using the GenSim framework. So to model, in order to know how to model a system or create a regulatory network using GINsim software, so let's begin with the GINsim software. First, we will open it. So GINsim, for GINsim, I have my drives. In the Google Drive, I have downloaded the software in softwares, and then here this is GenSim. So GenSim is Java-based software, and this is the interface of GenSim. So to open a new model, you can just begin with the new model. If you have already created a model, so you can open it from here. So let's begin with the new model. New model. Now, this is the toolbar. From the toolbar, you can draw nodes, and you can draw interactions or connection between the nodes using these buttons. This one is for to edit or to select a component, and this one is to create a node or draw a node, and this one is to draw a positive interaction and a negative interaction. And if the interaction performs the job of positive and negative both, then this is the interaction. And if the interaction is not known, then you can use this button. And if you want to delete a selected component, so you can use this button. So let me draw a node. So this, I have selected this button for drawing a node. If you click on this work area, so it will draw a node with the name G naught or G0. And if I want to draw multiple components, and I do not want to select this button again and again, then double click this button. So now you can draw as many components as you want. So now you can rename these. So let me first unselect this one by clicking on the E symbol, that is select or move button. So I want to draw a regulatory network with 3 components only. So let me first select this and delete this one. Now I want to rename it. I want to give this a name, E1. And when you change the ID for a component, then click in the work area, so it will be renamed. Then select another one and rename it E2 and change it. And similarly, E3 and rename it. Now, well, I want to draw interactions now. So for interactions, all these are positive interaction. E1 is a resource for, E2 is a resource for E1, and E1 is a resource for E3, and all these are positive. And similarly, E3 is a resource for, so first select the interaction and then, okay. So it means that if E1 is active, then it will activate E3. And if E3 is active, E2 will be activated and E2 will activate E1. So uh, now after drawing this model, I can like add the formula or logical parameter for each component, that how each component will be regulated. So for this purpose, what I will do, first select the component. Look for E1, E2 is the it's a regulator. So in the parameter, one method is to select the resource and make it a parameter for this. So E2, when E2 is active, then the value of E1 will be 1. Look, I have selected E1, so this is selected. So for E1, E2 is the resource. So the resource is available here in this right side panel. Now I want to make this like a parameter for it, a regulator for it. So select this resource. So and click on this arrow button. So it will be moved within this middle panel. So now it means when E2 is active, so the value of E1 will be 1. Mm. And similarly, you can define the maximum values for each component, like for E1. E1, when you select E1, so the maximum value of E1 is 1. So it means the possible values of this component will be either 0 or 1. So the E1 will be 1 when E2 is active, or when E2 is 1. Otherwise, E1 will be 0. So this is its meaning. Another method to define the logical formula or function or logical parameter for a component. So for instead of parameters, you can write the formula. So here to define a function, we have to click on this down arrow, and now the value of E1 will be 1. When E2 is available. E2 is available. E2 is active. So as this formula is correct, so I have got no error message. So similarly, to define the formula for E3, so click on this arrow, and the value of E2 will be 1 when E3 is available. So when E3 is available, so this is the method. So similarly for E3, the formula, let me define the formula. So for E3, E1, if E1 is available, active, so E3 will be active. So now as I have drawn this regulatory network, so now I can simulate it. So for simulation, go to the tools menu, and here you can see there is run simulation. So click on run simulation, and now there are different types of simulations. For to update the model, state graph model, You can use different types of updating modes like synchronous, complete, sequential, asynchronous. So mainly we are dealing with synchronous or asynchronous model. So first I will let you know about the asynchronous updating mode. So first choose asynchronous. And here the state transition graph, construction strategy, state transition graph. There are many strongly connected components graph as well. And here you can see hierarchical transition graph as well. So choose this state transition graph here and the asynchronous mode. And here from the perturbation, we have not selected and we have not defined any perturbation. We have not defined any reduction, and the rest is same. So click on this run button, so it will draw, and here you can select different layouts. So we leave the default selections and click on OK. So it has drawn uh, a state graph for the designed BRN, and we can see that there are two stable states, and there are cycles as well, or homeostasis between the states. So this is the state graph. This means all the arrows are incoming. It means that this state, if the system goes into this state, so there is no path to go out from this state. So it means this is a stable state. This is also a stable state if the system make a transition to this state. So it cannot, there is no way to go out from this state to any other state. So this means this is a state transition graph. I hope this video will help you in understanding how to draw a logical model, a regulatory graph, and how to simulate it. Thank you very much.